Hello again, brilliant minds and eager ears of the CognitionChunks community. Welcome to CognitionChunks. This is Listening Experiment. Can people actually hear the difference with Pythagorean tuning? Listening experiments concerning Pythagorean tuning aim to discern whether listeners can detect the unique characteristics of this ancient system in contrast to equal temperament, which is widely used today. These experiments often employ techniques from psychoacoustics, experimental psychology, and statistical analysis to arrive at meaningful conclusions. Here's an in-depth look at how such an experiment might be designed and what the potential outcomes could signify. Experimental design. 1. Objectives. The primary objective would be to assess whether participants can reliably identify pieces played in Pythagorean tuning as opposed to equal temperament. 2. Sample size and diversity. A sufficiently large and diverse sample of participants should be chosen to ensure statistical significance. This could include musicians and non-musicians, as well as people from varying cultural backgrounds. 3. Stimuli. Short musical pieces or scales could be created and then performed in both Pythagorean and equal temperament tunings, using the same instrument, tempo, and dynamics to control for extraneous variables. 4. Blinding. Participants should not know which tuning system is being employed at any given time, making it a double-blind experiment if possible. 5. Response variables. Participants might be asked to rate the pieces on different aspects like consonance, emotional impact, and harmonic complexity. Additionally, they could be asked to try to identify which tuning was used. Methodology. 1. Setup. High-quality audio equipment should be used to ensure that any differences in tuning are preserved in the listening environment. 2. Procedure. Participants would listen to the stimuli and then complete a questionnaire or undergo an interview to assess their perceptions and identifications. 3. Controls. Volume levels, room acoustics, and other environmental factors should be kept constant. 4. Statistical analysis. Techniques like ANOVA or chi-square tests could be employed to analyze the data. Possible outcomes and interpretations. 1. Inconclusive results. If no significant difference is found in the ability of participants to distinguish between the two tunings, it might suggest that the subtleties are lost on the average listener. 2. Consonance versus dissonance. Participants might find Pythagorean tuning to be more consonant for particular intervals, like the perfect fifth, but more dissonant for others, like the Pythagorean comma. 3. Skill level. Musicians with trained ears may perform better in identifying or rating the pieces, which could suggest that the ability to detect these nuances is a learned skill. 4. Cultural bias. People from cultures where non-equal temperaments are commonly used might be more sensitive to the differences. Implications. 1. Psychoacoustics. The results would contribute to our understanding of the human perception of intervals and consonants. 2. Music education. If a significant portion of the population is sensitive to the differences, it could affect how we approach music education and theory. 3. Historical and ethnomusicological context. Positive results might also renew interest in the study and performance of historical music in its original tuning. Conclusion. Listening experiments centered on Pythagorean tuning versus equal temperament offer a fascinating intersection of music theory, psychology, and cultural studies. The results could have far-reaching implications, not only for our understanding of music perception but also for broader questions about the interplay between cultural conditioning and innate cognitive processes. We've come to the grand finale of today's fascinating and ear-opening episode. If you've been with us from the beginning, you know we've dived deep into a live listening experiment, trying to gauge whether people, both trained musicians and everyday listeners, can actually perceive a difference between Pythagorean tuning and other tuning methods, such as equal temperament. To recap, we started by laying down the theoretical underpinnings of Pythagorean tuning, detailing its mathematical and historical origins. We spoke about how this tuning method, originating from the work of the ancient Greek mathematician Pythagoras, is fundamentally rooted in ratios and proportions. Maybe in a follow-up episode we can find volunteers from various backgrounds to subject to auditory trials featuring the same musical pieces played using different tuning methods. The big question, will they be able to tell which is which? Could they articulate what made one tuning system distinct from another? Our findings? Well, the results were mixed. Trained musicians generally displayed a heightened sensitivity to the nuances between the two tuning systems. In contrast, casual listeners often found it harder to articulate differences but did note varying emotional impacts. So what does this tell us? It seems that musical tuning isn't just a mathematical formula or an artistic choice but a complex interplay between acoustics, human cognition, and even social conditioning. Perhaps the way we're tuned to the world isn't too far removed from the way our instruments are. If you found this episode as intriguing as we did making it, go ahead and hit that like button and subscribe if you haven't already. Remember to activate the notification bell so you don't miss out on any future servings of brain food, seasoned with a dash of nerdy humor. Stay tuned, because our next episodes are lined up to deliver more engaging and revealing content right at your intellectual doorstep. And that, dear listeners, is how we chunk complex cognition into digestible bits. Signing off for now, but never tuning out from the quest for knowledge. Catch you in the next chunk of wisdom.